Hello and welcome again to another video on the NoSQL MongoDB version 4.4.1. The whole point of this video is as a way to understand what are the techniques and strategy use it and use in MongoDB, as well as improving my communication skill. Why am I doing this? Because right now, as a way to keep up the pace of MongoDB, currently, I'm working for a company that is using now Mongo 5, but the idea here is to understand how MongoDB has evolved and provide the best value for this company. So focus is on what they need on their user and expect and the user expectations and their needs. Basically, is that. So because now they have behind the scenes using is Docker as a way to containerize their application. So this little iOS that allows you to now deploy your application that works on any machine. And behind the scenes is using is Vue as a presentation layer, as well as the Node as a backend, with MongoDB as a Postgres. With MongoDB as database. So because previously I worked or in other videos, I also learning is how you can use, for example, Postgres version 14, and as a way to get yourself a practical sense of what are the things that you can do in SQL language like Postgres, this well battle tested database and ubiquitous, and now use it and look at how you can do that with MongoDB, with this NoSQL database. So this course is taught by Brian Hall. Shout out to Brian Hall, Jesus, completely. The software engineer that has previously worked at Microsoft, Reddit, Netflix, and he's currently the PM of Snowflake. This database as a service, uh, cloud cloud database as a service provider. Okay, yeah, database database as a service cloud provider. That will be much more accurate. And yeah, so yesterday we look at what are the tools that we're gonna use here. MongoDB version 4.4, as well as Node version 12 and 8 and superior. Why is this? Because this course was published is 4 years ago. But right now we can use any recent version of Node, which is, for example, right now they're using is the 20 version 20. I think it is interesting. Yep, version 20. That's right, with long-term support. Okay, and yeah, cool. So now, as you can see here, look at this. This is the way of how you can now create a simple simple web servers uh, using the EXIS syntax, which is using is the EX model syntax. Because before the EXIS models, we have something called CommonJS, which is it works exclusively in Node, and thanks to the JavaScript community that move on the language to actually create this as a standard, because after all, this is something that is being used worldwide. So yeah, and yeah, with a hash file. So yeah, it's actually very interesting. Stream pipeline as well, uh, completely, and work with threads as a way to now using is instead of using service worker, you can use now is workers. I mean, instead of using is cluster, okay, now you can use is worker threads. So this is now bringing JavaScript to be a multi-threading application, programming language. That's very, very interesting. So this is the learning materials and all of that. So you can see it's now using is or CommonJS, you know, or the EXIS or MGS, right? That's great. Okay, how to install, difference between Node and the browser, V8 and JavaScript engine, and this kind of thing, and so on and so forth. Node.js with WebAssembly, debugging, security best practice, and also describing is the asynchronous work for that, denial of service, the common one. Oh, there you got it. This is the threat list. Interesting. Interesting. Denial of service, DNS rebinding, exposure sensitive information to unauthorized author, HTTP request smuggling, information exposure through timing attacks, malicious third-party models, supply chain, memory access violation, secure heap, monkey patching. Uh-huh. Monkey patching, the supply chain attacks, memory access violation, monkey patching. So all of this series of threat and the security best practice for that. Uncontrolled search path, as well as this. But the whole point of this is not a Node.js course. It's just a way to look at that we're actually I am quite familiar with this. And so understand is some of the basics or understand now which is the current state at Node.js, which is on version 20, and how the thing that they have include version 20 here, right? Which is good. And well, with Mongo, that right now the vast majority of application on production they're using is Mongo 5, right? So they're using is Mongo 5 and 4. And once you're able to look at this timeline, you can see is that MongoDB, and because something that we're going to talk about, which is the terminology on a database. So when you need to talk to database people, you hopefully know what it. You hopefully at the end of this terminology section, you know what they mean by that. Okay, first is the database. After all, the TLDR. This is a repo that has that record millions of billions of things in there, and they meant to be used at planetary scale, and they can have resilience. So depend of this type of database, you can do certain things with that. Okay, so there is a variety of database that depend on what you want to do, they allow you to do. So for example, here we have is MongoDB, NoSQL, or SQL, as well as key value or graph. Also, something that is important to mention is something that we're going to talk about that later, the type of database. So first we clarify is what is the database, okay? That is a repo that allows you to store millions or billions of things, and it has resilience. So depend of the data you want to store, depend of what do you want to do, you have different type of database. The other is query, which is the action you perform to do something in the database. Okay, it's an action you send to the database to do something. Pretty much like if you have now express a machine and you indicate what are the things that you want to do, here it is. Each one of those are the actions that you indicate. Hey, give me an espresso. Give me like mocha, cappuccino, that kind of thing. Query, an action. The other is a schema. So because this indicate is the shape of the data, okay, there's some database that you must provide this schema. So for example, Postgres is a good example of that. And when you need to, or when you must, is to absolutely tell what will be the type of column, what will be is the key and the data of that, as well as the constraint. So if you're trying to give another key, they say, hey, no, I don't know what to do with this, and they're going to fail the entire query. Again, Postgres or SQL is this kind of type of database. The other is NoSQL, which is quite different. So they are schema-less for that. You also have another type of database, which is key value, and the Neo4j, which is graph database. And here, this is when it comes now the type of database. There is a nice uh, overview of database landscape article made by IBM when they talk about this in detail, and especially if you need to decide which type of database you want to go with. First, look at the license. Then you choose the type of database you want to go with, the family of database. Okay, uh, so uh, then you can say, okay, which one of them I would like to go. What are the main use case? In the case of relational database, the main use case are from or customer relationship management, e-commerce, or enterprise resource plan. Something that I actually working for a client that he is actually doing that. Uh, and then when it comes to work with uh, NoSQL database or document based, which are great for prototyping in the mobile development, as well as for shopping, event logging. This kind of database actually are, or if you want to show is a profile, this kind of database actually is what you want to go. So because by talking to this type of type of family databases, okay, which is the document, relational, graph, key value, and something called white columnar, okay, which is something that I don't. This is relevant to big Google tables and big. Yeah, this is something very specific to big table Google, okay, with Apache Cassandra, and they say that this is a two-dimensional key value, okay. There are other type of database as well. So, for example, like search engine, such as Solar or Sphinx. The Sol is for Apache, and they allow you to do this textful search. Or Sphinx, when you want to do a textful search in a web server. So that's interesting. And now you have, or and now Postgres and MongoDB has these built-in features, this search capability, search engine. So for example, when you use the I like or like, you are doing is a textful search. And you're indicating is which pattern you, which, yeah, which, what is the matching pattern for that? Whether if you're using is underscore or a percentage, interesting. And okay, Another type of database is this white column, something that we mentioned, message brokers, which is something that is very, the message broker is something that is very underused by Node.js developers. This is something very under, even though he mentioned that, okay? It's a vastly underutilized piece of architecture by Node.js developers that can really improve your flexibility and scalability without greatly increasing complexity. Is are exactly message broker are vastly underutilized or underused, underutilized. Yeah, message brokers, which is another type of databases, interested. This gives you the ability to pass message across your program. This is something vastly underused. Mhm. So you have Kafka, RabbitMQ, and Celery. So if you take a look at this, so because this is something that I have looked a lot in applications, okay, which is something that that have looked a lot. Apache Kafka, more than 80% of all Fortune 100 companies trust and use Kafka. It's an open source distributed event streaming platform used by thousands of companies for high performance data pipelines, streaming analytics, data integration, and mission critical applications. Streaming analytics, data integration, and mission critical application. 10 out of 10 manufacturing, 7 out of 10 banks, 10 out of 10 insurance, and 8 out of 10 telecom. See the full list. Largest energy and utility organizations. Insurance companies, manufacturing, information technology, and service companies. Largest telecommunication company. That's very, very interesting. High throughput, scalable, permanent storage, because this is a type of database, and high availability. But this is interesting because this type of databases, these message brokers, are allow you to exchange message across your program, building stream processing, connect to almost anything, client libraries, large ecosystem open source, trust and easy of use. So this is powered by Apache. Interesting. And I get it why this is what vastly used for that. Event streaming is the digital equivalent of the human body central nervous system. It's a technology fundamental for always on world where business and increasingly software. And the using is Apache for that. hmm But the using is Apache, RabbitMQ, which is open source as well. Okay. It's a reliable, mature messaging and streaming broker. Decoupling service, you have your backend, email and push, email sender, push notification sender, RCP, remote procedural call, streaming, upload new videos, analytic notification and transcoder. For streaming, and when you want to pass that data to each one of those as a way to analyze them and then send any notification and transcoder to pass to different servers, and the IoT, local Rabbit upstream Rabbit Okay. So this is another type of database, one broker to queue them all. And then you have Celery, which is for Python. I think Celery is written in Python for that. Introduction to Celery. Let me take a look at their star here in the GitHub. Distribute task queue development branch. Exactly. Mainly in Python. Exactly. Exactly. Keywords. Task queue, jobs, async, RabbitMQ, AMP, Python distribute for that. In the case of this is Celery. In the case of here, GitHub, get started here. Uh-huh. Okay. Okay. But it GitHub. So it's like having several clients. So this is written in JavaScript. Okay. 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 And then you have Apache Kafka, but I don't want to download that. I wanted to take a look at the docs. They don't have is any they don't have any GitHub repo for that. So Kafka repo, mirror of Apache Kafka. Okay, which is written in Java. Okay, okay. Okay, some of them are written in, so Kafka is written in Java. Okay, MQ is written in JavaScript. RabbitMQ website. Ah, but this is the website. Okay, not the. Yeah, they have several clients. Okay, they have several clients and servers. Exactly. Work, hello world, work queues, and publish and subscribe. Okay, routing, topics, and RCP. But again, this is something for exchanging message across across programs. Okay, message broker. Well, so yeah, this is something that is vastly underutilized piece of architecture by Node.js developer that can really improve your flexibility and scalability without greatly increased complexity. They allow apps and servers to publish event message on a system and allow the message broker to publish inform subscribers to those events that something happened. It is a power paradigm. Okay, so the paradigm here, paradigm, yeah, which paradigm is using this? Publish, inform, subscribe. Paradigm of message broker. What is the pattern that they follow? Message broker. Purpose. A message broker is an architectural pattern for message validation and routing. Message validation, transforming, and routing. It mediates communication among applications, minimizing the mutual awareness that applications should have for each other in order to be able to exchange message effectively, implementing decoupling, an architectural pattern. Hmm. But okay, an architectural pattern. Mm, an architectural pattern. Data integration, data architecture, analytics and business, master data and that kind of thing, data modeling. This is the entity relationship kind of thing, and there you got it. Okay, okay. Software design pattern and solution pattern. Okay, but the idea here is that by looking at this pattern, okay, it's an intermediate computer program model that translates a message, that formal messaging protocol of the sender to the formal messaging protocol to the receiver. So it acts as a broker. So the word broker is like a middleman. You say broker in Spanish, okay, un corredor, un agente, okay, broker is un corredor, un agente, perfect. Message oriented for that. So yeah, this is a way of how you can now, or this type of databases, which is something interesting that he mentioned that. So this type of databases, uh, this message broker, it now receive a message. Okay, it receive a message from it receive a message from the formal messaging protocol, and translate that into a protocol to the receiver. So this broker actually act as a broker between, but between protocols, as a way to exchange messages. Okay, okay, from one protocol to another. Okay, as a way to make this communications works, from different services. So a service that can be run on Node, and another service that can be run on Python, or it can be run on Go, and that kind of thing. Why we have this? Well, because again, depend on the type of database that you want to that you choose. Uh, there is certain thing that you want to go with, or you want to do with. So, for example, as I mentioned before, if you have a database that are good at this, it's good at business use case like ERP, CRM, or e-commerce, and then you want to communicate each one of those database to another server. For example, is taking care of the GPS reading in Go, which is very very good at doing multitasking operation. Uh, Now the way how they communicate, they need someone that actually can allow that communication. So a message broker is the way to do this. So transform is the message protocol from the receiver into a format, or into the protocol of the sender, or so it transform, or it translate a message from the it translate a message from the messaging protocol from the sender to a message to a messaging protocol to the receiver. Okay. So hey, what you want to do? Database. Hey, what you want to do with this? What you want to do, for example, if you have a Postgres here that store e-commerce. Okay, hey, what you want to do with this? With this user data that come from this, that whole is the store. Okay, I want to now go is to uh, process the several brick and mortar location that they have, okay, at real time. Okay, now I need to communicate to whoever actually have or hold that data or capable to do that data. Most likely a another server, another computer, in this case reading in Go, and actually can understand that. Okay, 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 all right, okay. In theory, in theory, in theory. Okay, okay, all right, okay. Hmm. 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 Google Cloud Pub and Sub. Again, this is very narrow specific when you have business that are communicating across different servers. Those servers are doing things in particular. For example, GPS. For example, handle the forms or storing data from all the users in a MongoDB or the relationship mm, across store and their products in a database. Holy moly. There's a lot of things going on, bro. There's a lot of things going on. Okay, so this is message broker. So now it makes a lot of sense. And the pattern that this message broker follow, a message broker is an architectural pattern. For message validation, transform architectural pattern. Hmm. Exactly, it's for the architecture. The primary purpose of a broker is to take incoming message from application and perform some action of them. Message broker can decouple endpoints, meet specific non-functional requirements, and facilitate reuse of intermediary functions. Okay, but this is an architectural pattern. Okay, this is an architectural pattern on two fundamental architecture: hub and spoke, and message bus. Hub and spoke, spoke and hub, spoke hub distribution paradigm, and the other is message bus. Spoke and hub distribution in the transport topology optimization. Completely, man. Completely. Emira is an example of an airline which operates using a hub and spoke. Hub and spoke. You see, spoke and hub. Hub and spoke. Exactly, but for the logistic in the telecommunication and information technology sector subsequently adopted this distribution topology, doing in the star network. Network topology. Hubbing involves the arrangement of a transportation network as a hub and spoke model. Hub and spoke model. But as you can see here, okay, um, this is something. This is a challenge on the real world, especially when you want to make sense of transportation and how you can now make an efficient distribution for traffic planners, organized around here. That's what message broker is an architectural pattern. Okay, that's what message broker is an architectural pattern. It allows you to do is message validation, transform, and routing. So it mediates among this application here. Okay, so pretty much like a broker. All right, interesting. Okay, all right. I don't need to know how that works. Perhaps only the pattern that they're using is the hub and spoke, and message fog. In the first, a central server acts as the mechanism that provides integration service, whereas with the later, the message broker is a communication backbone or distribute service that act on the bus. Additionally, a more scalable multi-hub approach can be used to integrate multiple brokers. But that's the message broker generally based on one of the two fundamental architecture, HubSpot. So message brokers, yeah, this is something vastly underutilized. Yeah, this is something vastly underutilized by Node.js developers. Yes, developers that can dramatically improve improve its performance, but or improve improve flexibility and scalability. Improve flexibility and scalability in theory. Okay, in theory. So message broker. So message broker is an architectural is an architectural pattern that handles message validation, message validations rerouting because it checks the message, transform that, message validations transform because you go from one message protocol to another. Okay, message validations, translation, and routing. Interesting. And then you got the multimodal databases here, uh, which it can act as MongoDB or Postgres. Have features that allow you to bend them into different shapes. Okay, this is just describing if the type of database. How important is to keep in mind of that? Okay, so you have is beside of the document key value. Okay, beside of the document, relational key value, graph, and white columnar. You also have is search engines. Okay, that allow you, for example, full text search. Postgres and Mongo already have these built-in features. You also have these message brokers that it take a message from one. It takes a message from the messaging protocol of the sender and transform them to a message of the and transforming into a message for the messaging protocol receiver. The idea of this type of database, which is very vastly underutilized, is that this is part of the architectural pattern. Okay, which means is that if you're going to build a web application, for example, part of the architecture is the client and the server, okay, as well as ACL, this access control list, or API rate limiting, which is another one. Service worker is another component here on this architecture. So with this, okay, that's interesting. So this message broker is part of the architectural pattern that they have a particular way of handle that, whether it's a message bus or hub and spoke. And what they do is message validations transforming in routing. That's interesting. So once you get familiar with this database people, okay, then you say, oh, this is what they do. This is what they actually need to want to. All right. It's like, okay, this is what they're going into that. This is what they mean by saying message brokers. Okay. Thanks, Brian Holt. Shout out to Brian Hall for that. So when you have to talk to this database people, it's like, okay, that makes a lot of sense. Good, good. Okay. Okay. Message broker, search engines such as Fins and Soar from. Okay, interesting. Another terminology is ACID. So ACIDs is this property, this quality property that database, not all of them, but some of them can have, which is atomicity. That this is the single transaction, the single query that it can happen. So does this query happen all at once, okay, or is this broken up into multiple actions? Sometimes this is very, very important question. If you're doing financial transaction, this can be paramount. Imagine you have two queries, ones that add $10 to one that one that remove $10 from a personal account, one that move that ones that yeah, one that subtract $10 from one personal account and add 10 to another personal account for a bank transfer. What if the power went on in between to the two queries? Money will be lost, and this is unacceptable. Trade-off in this case. So you will need this to be atomic. That is, these transactions cannot be divided. The other stands for consistency. That uh, if you have five servers and you have the leading one, okay, um, what happened when one of them crash or a subset of them crash, and then suddenly they up? So you need to also keep. So first, you will need to find a way to make those Slack servers keep up the pace. Okay, so you don't need to have your database in a wonky state. So consistency is allowed is one of these characteristics that some type of database must have. So you have atomicity. Hey, I need you to do this unique operation and guarantee that this actually happens in your database. Okay, as a way to make this transaction, especially in something true for financial service. I also want to have consistency in the database. So the data that I have, what happened when, for example, the powers go off and then and then going up. Okay, so where I don't need to have my data in a wonky state. Okay, I need consistency, and especially if you are building uh, applications worldwide. Okay, something that he mentioned here. Okay, so make sure that your database knows the truth, especially when you scale your application to multiple servers and suddenly some of them are down and later on up, and you need to find a way to make those Slack servers to pick up the pace. So you don't want in, and it can make your database out of whack, losing data in the case of money transaction. So the reason of using a lot of these financial transactions is because over the past 50 years, the banking have driven the development of all of this. And the features that we see is based on they need to. So they said that in that way. The same for isolation. Okay. So for example, if you want to now test individual things that happen in serial or in parallel, for example, if you want to make several requests, uh, if you want to make sure that those operations actually uh, perform well, isolation or integrity, okay, consistency, isolations, and the next one is durability. So what happened when your application crash? Okay, because first it's talking about is the consistency. You want the data be, you want a source of truth. You want your entire database have in a consistent state, has a consistent data. And the other is durability. So what happens when powers go off? Okay, you need to find a way to maintain a state that your data is durable. So all of these acronyms are just checkbox that your query must have, okay, or must be checked. And you might be thinking, well, I would like to make all of my transactions, all of my query assets. So that follow this by doing things. So, or in other words, is that by using all of these transactions as asset, okay. So you might be thinking, hey, I want to make all of my transactions asset, so I can guarantee this quality. Uh, the problem is that there is a trade-off with that because ACID is safe but slow. For example, in the case of durability, so if you query a database, uh, uh, yeah, if you make a query to your database, um, so it's gonna write into your main server. Say if you're querying your database uh, to store data, okay. So if you're querying your database, it will write on the main server, but also going to be writing out all of the other servers and waiting for all of the other servers when they all need to write on this, okay, when they're all going to be writing on this, and then wait for that, for all of this to happen before the query is marked as successful, before you actually store the data here. So for example, before you actually send $10 uh, to your mom. Hmm. Hmm. Okay, okay. This is when you need to explain this ACID transaction to a 4 years old. So ACID transaction, after all, is just quality that transactions, that queries must have. Not all database support that, but if you do, this is the thing that it needs to. Atomicity, okay? You only guarantee that this is being done only once, okay? This is the single operation that you can perform, okay? Atomicity, this also is a consistent that you need to have a data in a way that makes sense for all of the or for the entire database, which means that if you split your database across different servers, you need to make your data consistency across all of that. So for example, if a subset of servers uh, lose power, there was an outrage, there was an outage there, and suddenly they come up, you need to have a way to make the data consistency. Otherwise, if you have your database out of whack, you might lose data, you might lose money. The other is integrity of isolation, when you want to actually make that these individual transactions happen uh, uh, correctly. Okay, whether if you're performing a series of transactions or in parallel. And the other is durability, which is what will happen if your server crash. Okay, do you need to know is at which state, or do you need to know a previous state or some information previously before that? Okay, so you might be tempting to make all of your asset or you make all of your database ACID. Hey, I would like to go with all of this ACID operation. But there is a trade-off because ACID is safe, but it's slow. What does it mean that? For example, in the case of durable, if you are now sending $10 to your mom, so if you're writing a query if you're writing a query, or if your query is durable, you're going to write to the main server, and then it also going to be writing on all of the other servers. Wait for that, and all of those servers, they are going to be writing on their disk, waiting for that, and then waiting for all of these things happen. So it means that you're going to write your query to the main server. The main server um, is also be writing all. It also be writing in all of the server, uh, waiting for those servers, and those servers will be writing on their disk, and then you will have to wait for that, for all of those things to happen before the query, before sending $10 to your mom, is marked as successful. This is very low, particularly if your database is spread across the globe. For example, in banking system or in the financial system. So instead of waiting 5 milliseconds, you are now waiting 2 seconds to complete this query. That might be worse in the case of moving money around, but for the other things like updating an image profile, that's probably okay. Uh, uh, that's not totally consistent or totally durable. So there is an acceptance loss in data. And in other words, know that the trade-off, so what data is acceptable to loss or not, then you have to make choice on database around those things. So that's also what we're using is the example of the banking system. Is like, yeah, you need, so this has been driven by the banking system to solve this particular problems in over the past 50 years. Interesting. So from the 70s, okay, so over the past 50 years, this has been the problem that they have. uh, this is what has driven the development of this database, is the banking problems, and provide solutions to them, uh, over which is something that has shaped this last 50 years. That makes a lot of sense. And this is something where the value it is in the data, in the data management, manipulating the data, and then get some insight about it. Yep, totally. And the other is transaction. Okay, so transactions, so multiple queries that need to happen all at once. Okay, so the best way to put it, transaction is no matter how this database processing the query needs to work the same way. Okay, so no matter how Postgres, MySQL, document base, graph, white column, uh, message broker, key value process this query, the query needs to work the same way. Okay, that's the this is another way to put it. Transaction. So no matter how the database is processing the query must work, or the query needs to work the same way. Transaction. So I don't care what you're doing, okay? You need to guarantee that you are going to do. You need to guarantee to this transaction. I need you to guarantee that this operation, that this exchange happened. I don't care how you do that. I need you to guarantee me that. This is another way to put it. Okay? It's like I don't know. I don't. I don't care how you do the exchange. Just uh, so you must guarantee. Yeah, you must guarantee me that it will happen. That it will happen. Exactly. That's the definition of the transaction. So I don't care how the exchange. I don't care how the you. I don't care how the database do the exchange. I don't care how do you do the exchange. I guarantee. I want you. You must guarantee me that it will happen. Okay. So I don't care. I don't care how do you do the exchange. How do you do how exactly. I don't care how do you do the exchange. You must guarantee me. You must guarantee. You must guarantee me that it will happen. TLDR. I don't know how you do the exchange. You must guarantee me that it will happen. Basically, is this. Now, now that we know the terminology, it is time to take a look at here.
Four different types we're going to be looking at today of databases. A NoSQL database, which is a dumb marketing term like serverless, like any one of those other dumb marketing terms that you're familiar with. Um, what NoSQL means is that it's a database that doesn't use SQL.
Okay, dumb marketing.
The first of the four different types we're going to be looking at today of database is a no.
Okay, so right now you're not going to see me actually is writing this. You're not gonna see me is what I'm gonna do behind the scenes, because quite frankly is I don't want to receive any strike. I already received a DM in LinkedIn that someone from their legal firms at Frontend Master tells me, hey, you shouldn't record yourself. Okay, you shouldn't record yourself while learning. You can create a reaction video, that kind of thing, but you shouldn't record while you're learning. So because of that, well, that's the reason why you're not going to see the video. But I am actually doing. I am actually watching that. So okay.
The first of the four different types we're going to be looking at today of data.
Mm, So the first of the four different type of databases is NoSQL, 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 which is a dumb marketing,
Database is a NoSQL database, which is a dumb marketing term
which is a dumb marketing term like serverless. Exactly, because after all, you have a server. You don't maintain that, but you have a server. A serverless. Oh, man.
like serverless, like any one of those other dumb marketing terms that you're familiar with. Um, what NoSQL means is that
Exactly. So what no SQL mean is this is not a SQL
it's
database.
a database that doesn't use SQL.
Exactly. Is that is a database that is not using SQL, or that is not, yeah, that doesn't use SQL. This SQL query language, which is an standard, by the way, an ISO standard. International Standard Organization.
That's it. That's the whole thing of the term. It was a really hot marketing term in like 2010.
It was a really hot marketing at 2010
Something like that, and just stuck, right?
and just stuck. The power of marketing.
Um, it's a really meaningless term, but I'm putting it in so that you see it because you're going to be seeing it in documentation all over and in marketing material.
Uh, this terminology, you are going to see that in a lot of marketing material.
Um, it just means it's a non-relational database. So you're going to see that we're going to talk about SQL.
Yeah, it just means that it's not a relational database.
Databases here in a second. No SQL is anything that falls outside of that, which is a lot of things.
Exactly. Exactly. So NoSQL is anything that falls out of exactly. NoSQL is anything that falls outside of that. Outside of that, which is a lot.
What we're really going to be talking about today is a document-based.
So what we are really going to talk about is the document base. Mhm.
Database, which fulfills the no SQL paradigm.
Which fulfill fulfill the NoSQL paradigm. Paradigm.
This even gets a little bit fuzzier when you realize that some no SQL databases can handle SQL queries. So
This this even falls or this even get oh my god this even gets fuzzier when you realize that it might when you realize that you oh my god
paradigm. This even gets a little bit fuzzier when you realize that some
yeah this even get fuzzier this even get a little bit fuzzier when you realize
no SQL databases can handle SQL.
when you realize that oh my god when you realize that some NoSQL language databases can handle SQL queries.
Queries. So it's wildly confusing and dumb.
So it is wildly confusing and dumb. Oh my god, wildly. It's like wildly confusing and dumb. Document based. Okay. Oh my god. This even gets a little bit faster when you realize that some NoSQL database can perform SQL. So it is wildly confusing and dumb.
So yeah, these databases end up being quite dissimilar from each other, but still get lumped together. So there's a bunch of reasons that you would choose one of these. One of the biggest advantages to a NoSQL database is that
Okay, advantages. It is schemaless.
um, they're schemaless, right? So you can actually be defining a data like a data schema on the fly.
It's schemaless. You can define schema on the fly.
And it makes it really easy to get up and running with one of these. And it's
Mm-hmm. Making it very easy to get up and running. One of this.
also very conducive to the dynamic scripting kind of thinking that you would get from a JavaScript or a Python.
Okay, and very conducing to the dynamic nature of JavaScript in Python.
Schema on the fly.
Hmm.
And it makes it really easy to get up and running with one of these. And it's also very
Conducive. Conducive. The hell is conducive? Conducente. Uh, providing the right condition for something that good happens. Okay, conducive.
conducive to the dynamic scripting kind of thinking that you would get from a JavaScript or a Python type language. The mental models work well together, and it's why
Okay, it's conducive. Okay, the mental models works well together, and that's one of the use. That's one of the reasons why they.
we're going to start with this one.
The mental models works well together. Hmm.
The kind of the double-edged sword here is that
Uh-huh. Double-edged sword. Kind of a double-edged sword. Kind of a double-edged sword.
um, you never have to define databases up front. You don't have to define collections or schemas or anything like that.
Exactly. You don't you don't need to define database schemas or anything like that upfront. Okay.
But like if, for example, if you misspell something, the database will be like, "Oh, you're creating a new field."
Oh my god. But for example, if you misspell something, the database will say, "Oh, you are creating a new field," or you are creating a new field. Mm,
Here you go, right? So you kind of do
here you go.
have to be very careful about what's going in and out, and the more disciplined
So you have to be careful about what's going in and out. The more discipline that you can bring, the more discipline that you can, the more discipline that you can bring to your data structure. The more discipline that you can bring, okay, the more discipline that you can bring to your data structure, the better.
you can bring to your data structures, the more queryable it's going to be later.
Okay, the more queryable, queryable is become later, or is becoming later. Is more queryable is going to be later. is gonna be later. Hmm.
So um,
Great power
you know, with
comes, yeah. So great power comes with great responsibility.
great power comes great responsibility with data schemas. I think that that sentence was written about
With data schemas. Hmm.
data schemas in the first place.
Caveats of this.
Not Spider-Man. I'm gonna open my terminal here, and I'm just gonna paste that in the Docker,
Okay,
and they come out fairly frequently. Today we're gonna be focusing on one called MongoDB,
okay. Which is MongoDB. Exactly. MongoDB. But this is okay, document based.
which if you're a JavaScript developer, probably sounds fairly familiar to you.
Exactly. If you are a JavaScript developer, this is probably very familiar to you. Yep.
But there are plenty of others to look at, like Cassandra, Couchbase, Rethink. There's a myriad of other ones. This one's just very popular with specifically JavaScript developers, but in general with a lot of companies. So let's get into talking about MongoDB. I think it's pretty safe to say that MongoDB is one of the most popular databases today in the world. It's been a pretty reliable custodian of data for over a decade now, and it works really well with.
Okay. So I think it is pretty. I think it is good to say that MongoDB quite is very popular. It's very popular among JavaScript developers and companies because it has become the
Pretty safe to say that MongoDB is one of the most popular databases.
yeah. I think it is safe to say that MongoDB is popular.
Today in the world. It's been a pretty reliable custodian of data.
Exactly. It has become it has become a pretty reliable custodian
Data
of data for over a decade now. It has become a pretty reliable custodian.
for
Hmm.
over a decade now, and it works really well with like very small workloads. Like when I'm just doing like little one-off projects myself, I very frequently choose MongoDB just because it's really easy to get up and running with. The one thing I'm going to say is like if you go look through MongoDB's history, they've had a couple of rough patches. If like there's a time for like where they were like dropping data for a while. They had some rough patches. I'll just put it that way.
uh, they they have they have had some sort of yeah they have had some sort of uh, row pa- row patches.
Um, I'm just going to say that they're past that. They haven't had a real problem in a long time. So I
They haven't had a real problem in a long time.
I feel very confident in recommending to all of you. MongoDB is a very good use, or
Okay.
Good database for whatever workload you're going to throw at it.
So it is safe to say and recommend that MongoDB is a good database to whatever workload you throw at them. Okay.
Um, so let's go ahead and just dive into it.
Yep.
So hopefully you have Docker Desktop up and running now. You can tell if it's up and running here
Docker
in
desktop.
my
Okay.
Mac. You can see I have this little whale up here. You can see here it says Docker Desktop is running. Hopefully that's something you see right now. If you do, then great. If not, then you'll have to get it up and running. On Windows, I think it's in your system tray. Yeah, it'll be in your system tray as well. And then we're going to be running some commands that I have here just listed out for you. This should work in PowerShell. I didn't actually try it in PowerShell, but this should work in PowerShell. If not, you can use WSL and get into Bash, and this will definitely work through Bash in WSL.
Okay. So we need is to actually is here. So we need to actually here is to install Docker. That's what it is. To install Docker and run it.
Which stands for Windows Subsystem for Linux. If you just search for WSL Windows, it'll show you how to get that up and running. So I'm going to copy this Docker run.
Because now this is and run this command. Wait, sorry about that. Sorry about that. Okay. So here we are now saying, hey, I want you to run this container called test mongo that it will host. What you're gonna have is this. I want you to make this interactive and pass a port, which is something that is by default. And forwarding is this port as a way to say, hey, you know what? I want you to know is RM. I don't know what is RM means. With which this is the version that I want to.
And I'm going to open my terminal here. And I'm just going to paste that in there. Docker run dash name test dash mongo. You can call it whatever you want. I just call it test mongo because I'm not creative. Dash dit, that's for detach, interactive.
Detaching the interactive. Exactly. So once you run this, so when you run the container, detach from it and make it interactive.
TTY, that's what the dit stands for. Dash P, this is going to be what port you're going to be opening from your Docker container running on your computer to your local computer. So we're opening the port 27017 outside, so that's going to be the one that's going to be available on my host computer, and it's going to be opening 27017, which is the default port for Mongo interior on the inside, right? So you can kind of map those ports if you want them to be different. I don't, so that's why I'm saying that. The dash rm just means if when I'm done with it, just clean up automatically afterwards. And then the name of the container that we're going to be pulling off of Docker Hub.
After you're done, clean up.
Mongo. And then the :441, we're pulling the version 4.4.1. So if you run this, you should just get something like this. This is the hash.
This is the hash of the runner.
What's running inside of Docker. So if I type docker ps right now, you can see I have one container running, which is this one. You can see these numbers match up. You can see it's forwarding this port here, and you can see the name of this is test mongo. So now we have one container running on our computer. It's running MongoDB.
exactly. So we're gonna have this one running container running in our MongoDB, okay, which this version and this name, it means that we are gonna have is this one little computer inside of your machine uh, that is running now MongoDB and is exporting is internally in this computer the port 27070, and now you can access to the port here. I actually think they're gonna have some conflict. Yeah, I think it will give you some conflict. Mm-hmm. I think it will give you some conflict here. Yeah, I think it will give me some conflict here, especially with Mongo here. Yeah. So what if I would want to say, hey, stop that for a moment, okay? Stop that particular container. Okay, stop that Mongo. By the way, you did it. Great. Hey, perfect. Nicely done. Now what you do, in fact, actually is run this. Because here, da, 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 da.
You can see it's forwarding the Docker PS right now. You can see I have one container running, which is this one.
So after that, we'll have is one container running with Docker that expose at port 27.0.17 the Mongo uh, database version 4.4.1.
You can see these numbers match up. You can see it's forwarding this port here, and you can see the name of this is test Mongo. So now we have one container running on our computer. It's running
Mhm,
MongoDB. It's available for us to access.
exactly. Is available for us to access to this computer.
I don't actually have the Mongo client installed on my computer, but the container does. So we can kind of cheat and use the container's own Mongo to.
Okay, so I don't have the client the client app uh, for this example, but the container have but the container have and that's what we're gonna use, and that's what we're going to use. Okay,
Query against itself. So if you go back here to my notes, I have this docker exec command right here.
completely, and that is Docker, which is something that okay, let me run this. When able to find image mongo locally, now let me actually pull that data, which is exactly what it's doing behind the scenes, something that you can see right now. But let me show you quickly that, all right, which is here. That's right. So this is exactly what it did. So I run this command and tell, hey, I give this particular name test mongo. I want you to detach once you already pull the image and make it interactive, which is show me it's what's going on behind the scenes. And then with the port from this little machine or this little container, okay, uh, I want you to expose this the proper default port from this service, in this case MongoDB, and then I want to clean up things to install is the Mongo 4.4 version. So far so good. And now if you want to get access to this particular container, because here for this example we're not going to use this any client to get into this, we're gonna use this the client that the container provide. How can we access to that? By saying docker exec, okay, make it interactive completely. I want you to make that interactive, and I want you to run is the test Mongo, okay, which is the name of the container, plus the command I want to run, which is in this case exec. What is the command I need to run for that?
And I'm going to be connecting to my test Mongo
I'm
container,
gonna
and we're going to
go
be running the
is to
Mongo command.
Mongo command. Here we are. Holy moly. That's lovely. Da, da, da. All right. That's very, very interesting. Mhm.
And now you can see here, I am inside of Mongo, so I'm now actually able to query against Mongo. Now we're inside of MongoDB, and now we're able to start writing query. All database clients, or all databases have these kind of clients where you can get into the command line and start.
Mm-hmm. All these databases have this client so you can start querying your DB. All of these databases, all of these database engines have this client so you can start querying your database.
Doing queries. So let's look at one of these. If I
So you can start doing queries. Much better. You can start doing queries.
do show DBs like that, you can see here I have 3 different databases.
Okay, show DBs. Interesting. So what you say here, okay, now let me put it this way and expand this. Maximally expand, that's right. You say Mongo. Oh, it's actually correct me. But it's not like that. I want you to say show DBs. And it seems I need to pass this a semicolon. Okay. It actually tells you is all of these default databases.
One called admin, one called config, and one called local. This is what Mongo creates for you by default.
Mm-hmm. This is what Mongo creates for you by default. So once in there, run show DBs, show DBs, and this is what Mongo creates by default. Interesting.
Without you having to do anything. So Mongo has 2 kind of key concepts here. One is called a database, and one is called a collection.
Okay. So concept, key concept, document and collection.
And if you're familiar with like something like MySQL or Postgres or something like that, um, you'll be familiar with databases and tables. So a table and a collection are roughly analogous across.
Mm-hmm. So a table and a collection are roughly analogous.
MongoDB and like a relational database. So the first thing is we want to create our own database. A database is going to be a group of collections.
So the first thing here is to create a database. And a database is a collection of documents. No, it's a collection. It's a group of collections. Exactly. It's a group of collections. Okay, documents and collections. Databases.
So let's say you had an app that was running like a pet adoption, which is what we're going to be doing. So I always talk about pet adoption because I like dogs. That's really the crux of that issue right there. We're going to be using a database called adoption because we're going to have multiple different collections inside of this database. So it's a group of collections. You'll find frequently your application will only ever use one database. That's okay. If you have a bigger application that has a bunch of, this is users and this is movies and this is TV shows and you need to separate those out, you could have multiple databases which would then have multiple collections. It's all about organizing your data in a useful way.
So the thing here is all about organizing your data in a useful way.
But the idea is that you want to have like data together. So I'm going to say use adoption like that. That's going to be the name of my database because it's going to be a pet adoption database. You can see here now
Mm-hmm.
I've switched to DB adoption. That didn't exist before, but again, Mongo is dynamic in nature, so it just rolls with it, right? It's like you wanted something called adoption, here you go. I don't actually have something like that, but
Yeah. So for example, if you run now, uh, use adoption, and then you have to pass is switch to adoption. Okay, switch to adoption. Damn, son. That's scary because it's like, hey, this is how we create our first database called adoption. This is one of the thing of MongoDB. It's like
DB adoption. That didn't exist before, but again,
exactly that that didn't exist. That that didn't exist before. Okay, so that didn't exist before, but again, but again, MongoDB says, hey, but again, Mongo is dy okay. Mongo is dynamic. Is dynamic in nature. So it's
Mongo
a
is dynamic in nature, so it just rolls with it, right? It's like
so it just it just roll with it.
you wanted something called adoption, here you go. I don't
You just roll with it. You just want something called adoption. Here it is. Oh my god.
don't actually have something like that, but you can have it now.
Exactly. It's just roll with it. Similar to this scripting language like Python and JavaScript. Okay, you just go with it.
So let's talk about collections. Collections are just basically like a grab bag of documents, right?
So collections. Okay.
Document is going to be like a record, or if you're thinking about a spreadsheet, it's going to be like a row, right? So one individual entry into your database is going to be a document.
Mm-hmm. So if you think of this like spreadsheet, okay, if you think of this like spreadsheet, a document is like a row in a table, right?
And the table of those rows is going to be your collection.
Here, so the table and following the previous example, the table uh, of that row will be the collection.
So yeah, it's just a grab bag of objects. You can think of it as basically
So it's just a grab, it's just a grab bag of object.
JavaScript objects. In fact, literally, the query language for MongoDB is just JavaScript.
Okay. So the query model.
Objects. You can think of it as basically JavaScript objects. In fact, literally,
Mm-hmm.
the query language.
So literally, 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 the query language you use in MongoDB is just JavaScript.
For
Interesting.
MongoDB is just JavaScript. So if you know JavaScript, you already know how to do querying in MongoDB. So
So if you know how to do queries in JavaScript, if you know how to, yeah, so if you know how to, literally the query language you use in Mongo is just JavaScript. So if you know JavaScript, you know how to query data.
for example, I can just type math.now like that. Oh, it's date.now, not math.now. You can see this is actually just JavaScript. So you can actually just run.
So for example here, date.now, they actually tell you that. For example, date.now.
JavaScript stuff in here. So math.max, that would work, right? And that will actually just be copying and pasting some JavaScript in here to generate some records for us. Again, I'm going to be using the terms. The correct term to use here is documents. That's what each of these are. But I will use the term documents and records kind of interchangeably because it's just kind of fixed in my brain. Those terms mean the same thing. It's one entry in your collection.
So okay. So the term record and document is something that I'm going to use interchangeably. I am gonna use interchangeably because this is something that is fixed in my mind. Yep.
So let's make a database of pets, and let's insert a record into that. So I'm going to say DB. That's going to represent adoption, right? So that's kind of like the object that represents adoption right now. And I'm going to say dot pets. That's going to be the name of my collection that I'm about to create. And I'm going to put an insert one like that. And this is a
Mm-hmm.
function that you just give it a JavaScript object, and it's going to turn that into a record or a document in our database here. So it's going to have a name. And this name is going to be Luna, because it's obviously going to be my dog. It's going to be a type of dog. Its breed is going to be Havanese. And she is 8 years old. So that should look pretty familiar to you if you've ever written JavaScript before. It's because it's literally just
Because it's
JavaScript.
literally JavaScript here.
Okay.
So say
So
acknowledge.
if I hit enter that now, you can see it acknowledged,
Okay, this is
which
how you
means
can
that
now
the
populate data
query
to
was
that.
successful, and it inserted a new ID, and that object has an ID of blah. So every document that you insert into MongoDB, it just automatically gives it an ID. It has its own kind of internal ID system. Whereas with other databases, you have to have you have to create your own IDs. MongoDB automatically has one for you.
So that's something interesting because when you run for, let's go to create now a record or a document in our collection here or in our uh, database, which is database dot pet, just like that.
Generate some records for us. Again, I'm going to be using the correct term to use in your. So I'm going to say DB. That's going to represent adoption, right? So that's kind of like the object that represents adoption right now.
Okay. So DB is the object that is representing is the database where you currently are.
And I'm going to say dot pets. That's going to be the name of my collection
Exactly. That's going to be the name of my collections.
that I'm about to create. And I'm going to put an insert database here. So it's going to have a name. And this name is going to be Luna, because it's obviously
And then
going to
you
be my
say
dog.
now is the
It's going to be a type
insert
of dog.
one of
Its
name
breed is going to be Havanese. And
Luna
she is 8 years old.
Luna type dog. Okay. Breed Havanese. Havanese. And she has 8 years old. Okay, so way to get the feeling of how you do this. Holy moly. Holy moly. Alright. So now let's create a collection, a table, and insert a document, a row on that. So DB is the way how you say, okay, DB is the way how you reference the current table or the current database. the current database. Pets is the name of our collection. God damn it. Yeah. And insert one is the command to add record, add document, add one document to your data. Okay.
So that should look pretty familiar to you if you've ever written JavaScript before. It's because it's published, which means that the query was successful.
So it returned an acknowledge, an acknowledge object or acknowledge property indicating that was done properly, and the inserted ID, which is an auto generated ID, which is an auto generated ID from Mongo. That's interesting.
And it inserted a new ID, and that object has an ID of blah. So every document that you insert into MongoDB, it just automatically gives it an ID. It has its own kind of internal ID system. Whereas with other databases, you have to have you have to create your own IDs. MongoDB automatically has one for you. Let's take a look at that record then. So the first thing we'd say db.pets.count. And you can see now this has one record in it. And if I say show DBs now,
One document.
you'll notice that I do have an adoption database because it created that for me when I inserted that first document. So now it's like, oh, okay, now this is real, and it goes and actually creates all that stuff for you. Another thing that's going to be helpful for you is you can also say db.pets.help. And this
That's a
is
way
actually
to
going to show
see.
you all of the commands you can run. So
Okay. You can say db.count of db.count. You say, hey, db is not a function here. Perhaps some pets. It tells you one. And another helper function here is say, hey, what are the commands that I can run here? God damn it, bro. Holy moly. Okay, fine. Bold right. Count documents. Convert, create index. Create index data size. Delete many. Distinct. Drop index. High index. On high index. Drop indexes. Find. Count, limit, skip, store. Find one. Find one and delete. Okay. Exactly. Get DB. Get the DB object associated with the collection. Get plain. Get index. Insert. Insert one. Insert many as a way to do this batch insertion or this massive insertion. Map reduce. Aggregate. Map reduce. What? 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 Save object stat storage size. Okay, total size. Update one. Validate, get shard version, get write concern, set write concern, insert many, insert one, get index, get DB, find one, count and limit, skip sort, find one, find one and delete, That's interesting. Update one. Okay. Okay. Holy moly. Okay. That's interesting. A useful command. A useful command is like this. Okay, a useful command is like this. Okay, let me actually, in fact, put it here. Mm-hmm. Drop a collection. But as you can see, is this. Mm.
Find one, get DB, get indexes, all that kind of stuff. I frequently forget all this stuff, and it's nice to just be able to kind of see that at a glance. I think that also works for DB. We'll just check. It does. So you can see all the things that you can do with the database as well, in addition to the collection. You can do things like DB like stats, right? I think that works, right? So this is, it has one collection, one object inside of it, the average side of it. There's a bunch of stuff you can do to kind of administrative stuff. Yeah.
I keep hearing Brian say record. Is that the same as document?
It is. Yep.
Mm-hmm.
Those terms are not necessarily interchangeable, but I also can't get away from saying it because it's just kind of the word that comes to mind. But it's one entry in a database, can be considered a record, can be considered a document, a row. You'll hear it call all those different things. The correct term here
Is
is
document.
document.
Okay, that'll be all for this video. Take care. Bye bye.